Hi students, welcome to the chemistry sessions. So I hope everybody has revised the concepts of what we have done so far, that is the purification and characterization of the organic compounds. So just try to recall all the concepts because here I am to test your knowledge with a set of questions. So these set of questions will be including the purification, all the processes that we have done so far, as well as the techniques of detection as well as the estimation. So just have a proper hold over it and take out your pens, papers, whatever it is, we will be doing the calculation simultaneously. So let's just start off with the question number 1. What do we have here? The most suitable method of separation of 1:1 mixture of ortho and para nitrophenols is. So in this particular question, you have given the separation of 1:1 mixture. I have been given 1:1 mixture of ortho and para nitrophenols, right? So ortho and para nitrophenols, first of all, you will be requiring the concepts of organic chemistry also applied over here. And now the method they are asking for is maybe sublimation, chromatography, crystallization, steam distillation. So before moving on to the conclusion, let us just first analyze what all compounds are given. It's ortho and para nitrophenol. So you must be having an idea how kind of structure is it and what kind of a bonding is there. It's a special kind of bonding which is existing in the two structures. So let us just draw the structures first. First is the ortho nitrophenol, first I am making, right? So that is ortho nitrophenol, and the second is the para nitrophenol, right? So can you observe something over here? Yes, there is the chances of hydrogen bonding, and definitely there will be hydrogen bonding in each one of the cases, but it would be different in the two. How? In the first case, if you observe very carefully, I have got OH and NO2. So this hydrogen will be attracted by this nitrogen, right? So that is how the hydrogen bonding will be taking place. Can you see any kind of interaction between over here? Because here OH and NO2 group are far away, so there could not be any possibility of intramolecular H bonding. What will happen is there will be intermolecular H bonding, that means between the different molecules of para nitrophenol, right? So here it will be something like this. Maybe a molecule that would be like that, upside down arranged. So it could be any kind of possible arrangement resulting in the intermolecular H bonding. Here I am taking one of the cases. So that is how the H bonding can be taking place. So if I write this NO2 the other way round, right, and the OH also other way round. So what do we get? We get again the H bonding, right? So in this particular case there will be intermolecular. So what can you infer from this data? That there is intermolecular H bonding, right? What can you conclude over here? And there is intramolecular. So what do we conclude over here is there is the intermolecular H bonding between the different molecules. So intermolecular H bonding between different molecules will be making bonds in between the molecules, thereby making it less volatile. It will be very difficult for the molecules to escape out in the vapor state, right? So here, due to this intermolecular H bonding, there will be less volatility, and over here it will be more volatility, right? Why? Because more volatile will be corresponding to the molecules can escape very easily. So thereby this particular case will be having less boiling point, right? I hope everybody is getting it. Whereas this will be having high boiling point, right? Because the molecules cannot escape very easily, right? So as per the options given over here, sublimation is direct conversion of solid to vapor state. So that is not a possibility over here. Chromatography, I don't think so. Chromatography is when a particular mixture of compound is having affinity towards the stationary phase, right? So here there is no such kind of a stationary phase provided so that we can correlate it with the bonding of these molecules, right? Crystallization is getting converted into crystals, and steam distillation. So if you just look between crystallization, steam distillation seem to be appropriate depending upon the boiling point difference. So if we have got the different boiling points, we can have a proper steam distillation method for that. So first, having a less boiling point will be distilled off. Second, it will be having the more boiling point that would be distilled off, right? So that is why I am choosing D as my correct option. I hope everybody is getting my point and everybody has known the chemistry of what is going on in the molecules, right? So first you need to observe what kind of molecules are given, then jump on to some conclusion, right? Now, I hope that is completely clear. So let us just move on to the very next question. What does the next question say? Right, so it's the question for the Dumas method. You need to perform the calculations. So in Dumas method, for estimation of nitrogen, 0.25 grams of an organic compound gave 40 ml. So that is the value of organic compound. 40 ml of nitrogen collected at 300 Kelvin temperature. So remember where the nitrogen was collected? It was the nitrometer, Schiff's nitrometer, right? Collected at 300 Kelvin temperature, 725 mm pressure, that is the total pressure which is given. If the aqueous tension, they have been given the aqueous tension as well at the temperature, right? There has been the information about the temperature twice. The percentage of the nitrogen in the compound. So simple, you need to first go step by step, or you can just directly apply the formula. So I'll be going step by step. You need to perform the calculation simultaneously. So here I've got the Dumas method. Dumas and Geldahl's are very important methods. Most of the questions get repeated every year from these methods. So you need to be having a good knowledge about, or you can just mug up the formulas as well. So that would be really easy for you to just straight away put the values into the formula and get the answer, right? So in the Dumas method, what I have been given is, right. So I have been given the pressure, that is the total pressure. It's 725 mm. Aqueous tension is given 25 mm, I guess. Yes, right. So what will be the dry pressure of the gas? So first I need to find out that dry pressure, sorry, not dry pressure but pressure of dry gas. So that would be the total minus the aqueous tension, right? This is the complete moist pressure which is given. So it will be 725 minus 25 resulting in 700 mm, right? Now I've got the pressure. I need to convert these things into STP so that I can correlate it with the mass, right? So that is what we want to have. So I've got P1 which will be 700 mm. This is the experimental conditions that I'm taking, and here I'll be correlating it with the STP condition, right? So that is STP conditions, P1, V1. I need to apply the ideal gas equation. I hope everybody remembers what the process of Dumas method is. So V1 volume is given out to be the 40 ml, right? What else is T1? What is T1? The temperature that is given to be 300 Kelvin. You need to always convert the temperature into Kelvin. If not given, first convert it into Kelvin. P2, V2, T2. So we already know what is the pressure at STP, that is 760 mm. T2 is also, we know, 273 Kelvin. What I am left with is V2 at STP, volume of nitrogen at STP. That is what we need to find out. So once we find the value for the volume of nitrogen at STP, almost 60% of the work is done. So here if I apply ideal gas equation, so what do we get? P1 V1 by T1 equals P2 V2 by T2, right? So what you need to do is just put the values. 700 into 40 divided by 300 equals P2 V2 by T2, that is 760 into V2 divided by 273, right? So you need not to go into the details of this calculation because we will further be needing these calculations in my next step. What is the next step? So the next step is, now we want to correlate this V2 which is over here, which has been found in the unitary method. So it would be at STP, if I talk about 22,400 ml. That is what? The volume of a gas at STP. So this much ml of N2 will be corresponding to how much weight? That is 28 grams. We all know that is for the 1 mole. And this much volume, what will be the volume? Value of the volume will be V2 equals, or I am just straight away writing over here. So it will be 700 into 273 into 40 divided by 300 into 760 of N2 will be corresponding to how much? 28 divided by 22,400 into this entire value, right? So which will be, I am again writing it as it is, so this much of grams of nitrogen, right? So once you get the nitrogen, the grams of nitrogen, you can easily find out the percentage. For that you need the total mass of the organic compound taken initially. So what it is? It has been given as 0.25 grams. So it will be this much mass. So percentage will be this divided by 0.25 into 100. Clear? So here I would like to tell you one thing. You cannot apply approximations so much. Why? Because if you look at the options over here, it's 17.36, 18.20, 16.76. The values given over here are very close. If you perform the approximations, if you try to perform the approximate calculations, you might be having an error. That might, or that could change entirely your answer and it would be incorrect. So always whenever such kind of options are given in which the values are nearby, you need to perform the exact calculations. So what you need to do is, it's quite an easy calculation over here because you need to first cut out the values and then finally divide and get the answer. So I am not doing the calculations over here, I am just telling you the answer over here, which is 16.76, right? So it's just a simple division and multiplication. You can do it very well. So I hope everybody has got the answer. That was just a straight away question. You need to have a proper knowledge of the method, that's it, right? Now, let's move on to the next particular question, which says, right, so it's the time for the Lysines extract, the LE. So the Lysines extract is boiled with concentrated nitric acid while testing for the halogens. By doing so, what it does? So first of all, they have told us that they are boiling the Le with the concentrated nitric acid. Why they are boiling it? They are asking the reason about it before testing for the halogens. So just try to recall what we have done in the detection of halogens. Some two elements are interfering in the detection of halogens. That is why we add a concentrated nitric acid. What are those two elements? Those are, yes, nitrogen and sulfur. So we need to first remove these. So what are the reactions? Do you remember the reactions for that? So it is Le consisting of the nitrogen will be this compound, sodium cyanide plus HNO3 will give NaNO3 plus HCN. So this will boil off, right? This will be in a form of gas. Next is Na2S, that is the sodium sulphide. Again it will react with HNO3. NaNO3 will be formed along with H2S, again hydrogen sulfide gas. So these two gases, these two elements will boil off in the form of gases. We can now easily detect our halogens. No hindrance will be created by any such kind of elements. Clear? So that is the entire concept. You need to have a proper knowledge of that. And let us just check the options. Helps in the precipitation of AgCl. So that is not an exact answer, because there may or may not be the precipitation of AgCl. There may be AgBr or AgI. So that is not an exact option. Increases the solubility of the product of solubility product of AgCl. We are not concerned about the solubility product at all. Again AgCl, we are not confirmed whether the halogen is chlorine or not. Increases the concentration of nitrate ions. That is not at all relevant over here. Decomposes Na2S and NaCN if formed, right? So that is the exact answer what we have been given over here. So the correct option is D. Clear? Now let's move on to the next one. Next question. Question number 4. Right. Again we have got the question related to Dumas method, and as far as I think, it is a similar kind of question what we have discussed in the previous questions, and also only the values have been changed. So in Dumas method of estimation of nitrogen, now the organic compound has been given to 0.35 grams of an organic compound gave 55 ml of nitrogen. So earlier it was 40 ml, now it has been changed to 55 ml. If nitrogen collected at 300 Kelvin temperature and 715 mm pressure, that is the total pressure they have been given. So what will be the dry pressure? The dry gas pressure. The total minus the aqueous tension. What is the aqueous tension given over here? I hope everybody is getting the question right. So it will be 700 mm. So I am not going to discuss the details of that because it's more or less similar. We will be now just putting the values. What are the values here? So as we have discussed earlier as well. So I will just change the values over here. Here the entire scenario is similar. I need to just change the values. 700, that was the pressure, right? 300 Kelvin, that is the temperature also in this question. 273 Kelvin, completely right. 40 ml will be changed to 55 ml. And 760 remains as it is, that is the pressure at the STP for any gas. And what else we have got? The total mass of the compound, which will be 0.35. It's given this time, and that's it. You just need to perform the calculations and you are getting the answer. So here the answer will come out to be 16.45. So that is what you need to get, right? Now, let's move on to the next question. I hope you are able to perform this question on your own. The best method for the separation of naphthalene and benzoic acid from their mixture is, so I have got naphthalene, I have got benzoic acid, that is the mixture that I have got, right? Chromatography, is it? I don't think so. Let us just move on to other options first. Crystallization, it may or may not be. Distillation. So let us just first check, before having a confusion, what all compounds are given. Naphthalene, if you recognize, it is a compound, something which directly volatilizes, right? From solid it sublimes into the vapor state, right? So it is sublimable, right? So can you see an option which is correlating with that? If you just observe benzoic acid, so benzoic acid is, if I am trying to sublime my naphthalene, benzoic acid is not a compound which is sublimable. So it can be separated easily if I carry out the sublimation, right? So that is why we can have a proper sublimation method for that. Clear? So it will give, definitely it will separate the mixture of both of the compounds. I hope that is completely clear to you. So just having a knowledge about one of the compounds can get our answer right. Now, let's take up the next question. In steam distillation of toluene, the pressure of the toluene in vapor is. So, remember what steam distillation is? What you do is, you distill, you boil off one of the compounds along with the steam, but steam is not miscible with that particular compound, and the pressure of atmosphere, right? What is a boiling point? Boiling point is whenever the pressure of the substance which is kept inside the vessel is more than the atmospheric pressure, then only it boils off. So what happens in steam distillation is, the atmospheric pressure is equal to pressure of compound which we have taken plus pressure of steam, right? That means what steam distillation does is, it lowers the boiling point, it lowers the vaporizing point of the compound which has been taken in the vessel. So that is the basic criteria for steam distillation. So as per the options, in steam distillation of toluene, the pressure of toluene, they are asking about the pressure of toluene in vapor is equal to the pressure of the barometer, is it? No, because here the pressure gets reduced a little bit due to the presence of that steam. Less than the pressure of the barometer, yes, it could be the option. Equal to vapor pressure of toluene in simple distillation, no, it does not correlate with steam distillation. More than vapor pressure of toluene in simple distillation, not more, not equal, but less, right? So if these two options would have got the less vapor pressure, then it would have been correct. But over here, these two options, due to the presence of this equal word and more, will not be the appropriate. What is appropriate is less, right? I hope everybody is clear with the concept. If not, just try to recall, try to revise the concept for steam distillation, what all is happening into the steam distillation, right? We have already discussed that in a session relating to the steam distillation. So just go and check it there. Now comes up the question for the Lascine's extract. Again, Lascine's test for the detection of nitrogen fails in. So you need to just choose one of the options in which the LE test will be failing for nitrogen. So for nitrogen, what is the LE test? The nitrogen that is present in the compound is made to react with sodium, right? Also carbon, the carbon that is present in the organic compound, and what we get in LE is, we get NaCN, right? That means for a Lysines extract to have sodium cyanide, I need sodium, that is for sure. I need nitrogen, that is also for sure, because I am testing for the nitrogen, and also along with that I need the carbon to form the sodium cyanide, right? So that is the basis. Now if I just check the options, in this option and out of all the options, can you see a compound in which some kind of element is missing which would not represent, which would not form this Le? So I need carbon specifically, I need nitrogen specifically. So over here nitrogen is present in each and every compound. What is not present is, what is absent is the carbon in one of the compounds, that means B. So B would not be giving Le. Carbon is absent, right? So that is the correct option. Clear? Now if you just check the remaining three, every option has got carbons and nitrogens which is capable of forming the sodium cyanide. Clear? Now let's move on to the very next question. In sodium fusion test, again a test for Le. Sodium fusion is also nothing but the Lysines extract test. So sodium fusion test of organic compounds, the nitrogen of the organic compound is converted into. So it's completely simple, we have just discussed this, that nitrogen plus Na plus C, we get cyanide, sodium cyanide, and not sodium amide, not nitrite, not nitrate. These two options are just given to confuse you, right? So that is the correct option. You need not go into the detail, it's just a simple reaction and the question is based on that. Clear? So I hope everybody is enjoying this test over here, because it's quite a simple one. Now the second last question, what do we have of Geldahl's method? So Geldahl's method is used in the estimation of, so it's very simple. There are only two tests for the estimation of nitrogen, that is, one is Dumas, other is Geldahl's. So I hope everybody remembers that and we easily get the option A as the right one. Clear? Not halogens, not sulfur, not oxygen. Clear with the idea? What is the test for halogens known as? The estimation of halogens, that is Carey's tube method, right. Sulfur is also carried out in Carey's tube. And oxygen, it has got a different kind of method, or we can apply 100 minus the sum of the percentages of all the elements which have been found in the organic compound. So that is also another method for oxygen, but not Geldahl's, right. So now let's move on to the very last question of this questionnaire. Right, it's Prussian blue is formed. Quite an important one, because questions relating to Prussian blue always come. So they have got a maximum possibility of coming along with what we have discussed in Dumas and Geldahl's. So here Prussian blue is formed when? When is Prussian blue formed? First of all, it's for the detection of nitrogen. I hope everybody has got that. So I've got the Le, right? What I need to do is, we add ferrous sulfate, then we add concentrated H2SO4 and we get Prussian blue. So that is what, but here they are asking about the internal chemistry of that. That means you need to have a knowledge about the reactions which are going on. So ferrous sulfate reacts with FeCl3. Is it so? No, we put ferrous sulfate in here and what we get is, we get hexacyanoferrate. We get this compound. So just remember that, right? And what else? What is the next step? This ferrous ions on adding concentrated H2SO4 may get converted to Fe3 plus ions. Now these Fe3 plus ions will react to give another compound, right? So that is what we need to have. So this particular compound will react with Fe3 plus ions, right? And what we get is this particular compound, right? Now let us just correlate our answers. Okay. So the answers over here is ferrous sulfate reacts with FeCl3. There is no point of FeCl3 first of all. So I am just terminating this option. Next is ferric sulfate reacts with this particular compound. Is it so? Yes. Just look here very carefully. Ferric ions have come up from the ferric sulfate, which has been formed in the reaction mixture due to the addition of H2SO4, right? So this ferric ion is coming from the ferric sulfate. Also, it is reacting with what? This particular compound. If you correlate it with this and if you just try to complete this reaction, I can counteract this negative charge with Na4. 4 Na positive ions just to make it a neutral compound, and that is what also given over here in this option. So I hope this would be the correct option, but let us just analyze the remaining two. Ferrous ammonium sulfate reacts with FeCl3. Not a point over here of ammonium sulfate. Ammonium sulfate reacts with FeCl3, is it so? No. So both of these options are also incorrect. We got our answer over here, which is B. I hope everybody is clear with it. So that was quite a revision of the entire chapter. So we have covered the purification, we have covered the characterization, the detection. So if you have just observed, the detection related to the nitrogen has come up more. Also the halogens. Also what we have observed is the Dumas and the Geldals have been focused a lot over here. So you need to have a proper revision of the entire chapter once again. Just go through all the questions, and you can also pick up as many questions as possible, because this is also an important topic. 1 or 2 questions every year gets repeated in NEET, right? So I hope you have enjoyed the question around. I'll be taking up the JEE main and advanced pattern exercise in the upcoming sessions. Till then, have a very good day.